Hello, everyone. Thanks for being here. I want to show you our open source Smartwatch project based on Zephyr. So I've held a similar presentation last year, and from last year to now, a lot of things has happened, and I want to show you the new way the project goes and all the changes we planned and some cool, nice ideas and features. So let's start. The agenda. First, I want to say a little bit about me and about the project, the so to say old project, and then I switch over to the new start from beginning of this year. The new hardware, the software enhancement we did. Then a little bit of a live demo where I want to show you the different aspects and ideas of this project. Then we have a little sight into the future. And last is how can you support us, and some Q&A if we have time. Let's see. I'm Daniel. I'm from basically Nuremberg. I'm living a little bit outside of Nuremberg. I'm 35 years old. I'm a passionate electronics engineer, and I obviously do a lot of software. And I'm currently working as an electronics or embedded engineer at ETO in Nuremberg. It's a huge automotive, an automotive supplier, and there I do a little bit of electronics development with firmware and so on, Linux side and also MCU sided. And I've joined the project in August 2023. So the project was originally started by Jacob from Sweden. He did this project while his wife was pregnant, and he said, okay, I have this cool idea for a smartwatch. I have 8 months of time. How can I build a smartwatch from scratch in 8 months? And then he said, okay, I have this Zephyr. There are lots of sensor drivers. Let's see what drivers are there. What can I use? And then he picked everything, put it together, and then he had a smartwatch, and I saw this project in January 23, I guess, and I thought, hey, it's pretty cool. Place it in a bookmark somewhere, forget it for half a year. Then my wife got pregnant, and I decided, hey, okay, I have 9 months free time before the child is there. And I have this cool project, let's do something with it. And then I asked Jacob, hey, let's do something cool new with this project. And we decided to improve the existing project. And there you can see the final and last stage from last year. So we have this cool metal housing and this really nice PCB with a lot of stuff, and a Nordic MCU and Zephyr on it, a display, a vibration motor, a battery, and this round PCB there is a programming dock with an onboard debugger, proudly presented by Sega. So we got a bunch of licenses from them to build our own programmer, and it was really cool. It worked quite well. We also had this nice transparent housing up there, which is 3D printed, and it looks really, really cool. And the idea of this project is it's a smartwatch. It should look nice, and it should be completely open source. So no binary blobs, no proprietary stuff, and so on. You can build it on your own. You can buy the components on your own. You can repair it on your own, and you can modify it as you want. And you have no restrictions with the smartwatch. And of course, you can connect it to a mobile phone to have smartwatch stuff ready there. Okay. So here you have an, how is it called? I think explosion view or something like that. So this device is really, really tight packed. So it's not that easy to assemble it. You have this PCB, this 3D printed bottom part where the PCB is mounted on. Then you have a 3D printed inlay where the battery is located and the vibration motor. Then the display is mounted above the battery, and then you have the upper part of the housing. And you squeeze it all together, not too hard to not break something. Then you screw it together and hopefully everything is working and you have a smartwatch. If you did some mistakes, then the display or something else is not working and you have some problems to disassemble everything. So it's nice, it's working really good, but it's not for everyone. So you must be a little bit of a techie and some hacking guy and so on to build it on your own. So it's not nothing you can, for example, give your parents and say, "Hey, I have a nice smartwatch for you." And it's obviously a little bit bigger than Apple Watch or something like that. So don't expect something slim like an Apple Watch or something that leak. So then, December last year, we had the luck that the NGI Zero, it's an European fund located in the Netherlands, said, "Hey, here you have a bunch of money. We want to fund your project." So we got a really big bunch of money, and we said, "Okay, it's nice, it's cool, but let's rethink the complete project." So we say, "Okay, we leave the state, the current project state as it is, so everyone can build it. Can still build it. Sorry, but we want to improve it. So we want to move away from this techie style smartwatch and get a smartwatch which is much simpler to build for everyone. So also non-tech guys can build it and use it. So, and for this, we have to rethink basically everything. And we also want to add new features. So a lot of people have asked us, where's the heart rate sensor? Where's the health sensor and so on? Why your smartwatch doesn't have a health sensor? And we always said it's damn complicated to integrate it into a smartwatch. And there are a lot of downsides in the current design which prevents us to implement it. But now we say, okay, we want this, and it should be in the smartwatch. And we also want to improve the hardware. So we decided, we did a development kit with the smartwatch hardware. So you have a much bigger PCB on your desk where you can measure and debug and cut something or break something and everything you need to figure out issues in the hardware or in the software. And when we shrink down this PCB and create a new smaller one, which is the new watch PCB, we want to reinvent the dock because we said, okay, it's nice that we have this licenses from Sega, but to be honest, such a license is very cost intensive and we want to shrink down the prices. So we moved away from this onboard debugger and decided every Nordic board has a debugger attached to it. Just buy this stupid NRF 54 development kit for 20 euros or something like that and use this debugger. It's much cheaper than this Sega license later on. And just connect this board to our dock and then you can flash the watch. And then we need this heart rate stuff. Heart rate is really complicated, and it was a lot of pain to build it up and to test it and write software for it and talk with the companies and so on. So we decided to do it in the same way as for the watch. We built up a development kit, which you can use for testing, and then we built the official extension for the watch to add the hardware sensor to the smartwatch. We want to improve the software. So the software is really messed up, like this coffee caller software in a much more messy way. So it's a real mess. And we have to clean it up, and it's a real pain. And because we are lazy, we say, okay, we need more CI/CD. We need CI/CD for the application, we need CI/CD for the hardware project, and we need CI/CD to test the software on the hardware because we don't want it to do it on our own. So we decided we grab a Raspberry Pi, put on some CI/CD with a debugger, attach this watch PCB to it, and develop a hardware in the loop test for the smartwatch. And we have a bunch more topics like the housing and so on, which are also a topic for the redesign. So all projects are built with KiCad. So we have basically the first revision of development kits ready in the dock. We are still testing them. We have this nice keyboard automation for KiCad, which generates a really big documentation with everything you need. So you just do the hardware, push it to GitHub, run the CI/CD, grab a coffee, and after 5 minutes you have everything. Grab this and order it, and it's fine. No more handwork and no more issues with this output files. So how does the hardware look like? This is the watch development board. So we have a bunch of stuff here, a microphone, some sensors, an RTC, this nice NRF53 MCU, NOR flash attached with quad SPI to the MCU because we need a lot of flash. Obviously, currently we use the complete 32 megabyte flash with our firmware. So display connectors, some buttons, a lot of jumpers to disconnect the sensors from the power supply so you can measure the current consumption, haptic driver, and Nordic PMIC. And this board, we cut it down to 7 to 10 microamps current consumption with the complete watch software. So it's really nice. We achieved it yesterday after 1 week of weird error finding. So it's a huge milestone. So the dock looks like this. So we have this USB-C connector where we have USB 2 on it, SWG, debug interface, UART, reset, and I think that's all. To have a nice solution to connect it with the watch and have all the nice interfaces. You can hook it up to the PC. It's basically a USB hub with a UART to USB converter and overcurrent protection. So really dumb, no license on it, and you can hook up your debugger to it and debug your watch. So hardware development kit, it's basically this. So it's an NRF54 to have Bluetooth, and we have this biometric sensor hub with an analog front end and 2 photodiodes on the bottom side, and you can use this nice looking board and place it on your wrist and wear it as a watch, and then you can test it. So you can go outside, do some walking, and collect your heart rate data, and hopefully it works. And then you can test it.
No more external flash?
No, because it's just a Bluetooth heart rate sensor. there are no UI elements and so on in the firmware, so we don't need that much flash, luckily. Yeah, one of the big software enhancements, we have OTA, finally, via USB and Bluetooth. It's managed with this MCU manager from Zephyr. It uses this nice web page created by Jacob. You can upload some firmware, do update via Bluetooth with it, or you copy your firmware via USB on the file system, and the watch does the firmware update. And it's nice for if someone else doesn't have a programmer to update the firmware. So it's really cool. Yeah, one big software enhancement is also we use this external flash completely now. We have this nice integration, so we can run code from the flash now. And we use the Zephyr code relocation to move all this LVGL UI stuff into the flash, because it bloats up our internal flash and it's a real pain. We have a second partition on the external flash for the bootloader, and we have settings storage, and yeah, and that's basically all. Later on, we want to use it for this LLX extension, but it's just an idea for now and does not work currently. And just to give you a number, the external flash is completely filled, and the internal flash is also nearly completely filled. So we are on 99% flash usage on the NF and on the external flash, and we only use 2 megabytes for the as an partition for the USB interface. So the rest is all firmware stuff. Yeah, caused by the Bluetooth stack and the USB stack and all this UI stuff and so on. So software, another software advanced enhancement is we worked on CI/CD. Because we said, okay, we want to sell the watch as a kit. So it would be nice when we can test the hardware automatically and not with a multimeter or oscilloscope, and then you break something and it's always shitty. So Jacob decided to first use a Raspberry Pi, and then he bought a small PC on eBay. One a runner on it, connected to GitLab, attached a J-Link to it, and now he can test the firmware after each pull request automatically on this hardware. And we got a nice report with current consumption and hardware tests and so on. It's all built with the Zephyr, with the Z-test framework from Zephyr, plus a little bit of Python to hook up the J-Link. We finally upgraded to LVGL 9. Luckily, it was also a bit of mess. We have this nice POSIX build also to develop the firmware on our PCs. One downside of this POSIX build is we don't have sensors on our PC, so we need emulated sensors, and we started with emulated sensors for POSIX last week, and we got our first sensor working. So the light sensor is now working with POSIX, which is cool. Now you can use the light sensor on the POSIX builds, and that helped a lot, but it was the easiest sensor. So the IMU and stuff like that will be more complicated, I guess. And we decided to contribute our sensor drivers to Zephyr. So, for example, this APDS 3906 sensor driver is contributed by me. This biometric sensor hub driver for all this hardware stuff is still in review. It's a lot of code, obviously. And we also pushed this RTC driver to Zephyr, so it's completely functional, and you can use these 2 sensors. You can use these 2 sensors now, and the biometric sensor hub will hopefully be done in a few weeks, something like that. Not sure. Yeah, live demo. I make it quick because not much time. So as I mentioned before, we have this nice POSIX build. Oh, come on. Yeah. So we have this nice POSIX build. I compiled it a little bit before because this PC isn't the fastest one. So you have this watch UI. You have everything as in the watch. You can change the watch faces to different. You have notifications. And you have a lot of applications. So, for example, Jacob finished the microphone integration. So you have this nice spectrum analyzer for the microphone. You have music, settings, stopwatch, and timers, obviously, based on the RTC. Weather from the smartphone. We have subdirectories now, which is some way nice. There you have, for example, a battery application which uses all the features of the PMIC to give you a power estimation and so on. Obviously, it's not working in with POSIX build because I don't have a PMIC here. Yeah, fitness, but to be honest, I don't know what this does. It's a new application, yeah. So system where you have this about application debug. So we had the issue that the watch crashes all day long if you are outside, so you don't have a debugger or something like that. So we decided, it would be nice if you have some memory dump if the watch crashes, so you can download it at home and check what the issue was. And this is basically this application. Update for Alter, watch face picker that you have seen before. Yeah, some games. The games doesn't work with LVGL9, and we don't have any effort to fix it now because it's not easy. Sensors, Compass, for example, sensor fusion for combining Compass and IMU, and this sensor application which basically lists everything from the sensor. Doesn't work because we don't have sensor emulation currently. And random, some random stuff, right? So it's really nice for development, as the guys before mentioned. And we also have this CI/CD. So this is a report based on the CI/CD test on the from the hardware and the loop test. So on each pull request, this is automatically generated. It's also really nice, so we can see the current consumption, and we don't have this surprise that a newer firmware will brick our low energy watch like in the past. And yeah, I mentioned it before, we also have this keycards automatic releases, which are generated if you create a pull request, then keyboard is running and generates a lot of stuff and creates a release for GitHub. And there you have, for example, a fully documented schematic, a little bit small, it's a bit like Altium, so it's a block diagram, revision history, the schematic itself, and so on. And you got a lot of documentation from it. It's really cool. It took a lot of time. Was it necessary? I don't think so, but it's cool. So it was a side project for me, to be honest. So we haven't planned it before, but I like this feature. How we want to continue. We want to improve the housing with the help of an external mechanical engineer. We found this guy, I think 2 weeks ago. or something like that. We want to complete the prototype testing. It took a lot more time than we expected initially. We got a nice request from Electro, so they want to sell our stuff. So Jacob is in discussion with them, but obviously we cannot sell something that we don't have for now. We have to do documentation stuff, so the code is basically not documented. The blog is updated each 1 or 2 months, so we are very lazy in this topic. Heart rate, as I mentioned before, is a real mess. So as we finished the heart rate sensor, Maxim told me, yeah, this solution with the sensor up is unofficially discontinued, so I would switch. And it pissed me really off because I spent 2 months in the electronics and in the software, and then they say, yeah, look for something else. But we decided to continue with it as long as we get the parts. So let's see how it goes. No, I'm not sure, to be honest. And exploring LLX to swap out applications easily. We tried it once. It doesn't work. We don't know why. And we decided, okay, it's an early stage of this, so let's drop it. It's unimportant and we don't have time for it. But it would be really cool to upload new application via USB, but yeah. So how can you support us? Follow us on GitHub. So we have a lot of projects there. You can subscribe to the blog for the latest updates, or LinkedIn, or use the newsletter from the blog. You can contribute to the project with software or hardware or ideas or something else, or a smartphone app or something like that. Or if you have money, we also take it. You can sponsor us obviously. So you can decide what you want. Feel free. So thanks to the NLNet for the funding. It was really nice. We don't expect it to get the full funding from them. So it's that much money that Jacob can do 2 days in a week as a full-time job for the smartwatch for 1 year, and I can do 1 day in a week. So we cut our regular working time to work on the project. And obviously, PCBWay, we order all our PCB stuff there, and they also supported us with some fundings, and we have won some nice hardware contests there, which gives also a bit of money. That's nice for prototyping, to be honest. And yeah, you can scan the QR code if you want to stay in touch with me and talk about the project. On the table, you find a small white box with some prototypes, so you can grab them, check them out, talk with me. Please don't take them with you. I don't have much more than this. And yeah, that's all. And yeah, nice. Perfect time. So very quick Q&A.
It's not so much a question. It's just you've pointed out LLEXT or LX.
Yeah.
I'm a real big fan of that. I think it's like a total game changer. I think it's going to be really good. Were you looking at it from the perspective of the user being able to kind of upload their own applications, or from a firmware perspective, where you just kind of help?
No, the idea for LLX is that a regular user which hasn't a programming device or isn't tech savvy can upload a new application via Bluetooth or USB or something like that. A very big idea for the future is something like an app store where you can download binaries, so to say, and then you upload them to the watch. But it's a lot of work to do, and currently LLX causes some trouble with the file system on the flash, so it always crashes if something happened. We don't know why. it's not good currently, and we don't have much effort or time to investigate into it because we have a big list of tasks that we have to do, and LLX is more or less a nice idea for the near or far future. Not sure.
Yeah. For your testing setup, are you using USB right now to parse the reports coming from Twister? Or RTT? Or what?
We do it via the J-Link. So it's we connect the watch with the debugging interface and trigger the firmware events. I think with the J-Link.
Okay, but how you read the reports? You read it over RTT or what?
The results are read via USB. The J-Link is connected to the Raspberry Pi, and the runner runs on this Raspberry Pi, and you have some Python scripts and the Z-test framework that read the results from the watch via RTT, and then the CI/CD script generates the reports.
Did you try also the integration with PyTest to measure the haptics?
Maybe
for example,
it's PyTest. It's built by Jacob. To be honest, I don't spend so much time to look into it because it doesn't work on my lab. So yeah, but it's done over, via the J-Link and Raspberry Pi and a local runner on the Raspberry Pi. So you have some glue codes there with Python to connect the different parts, and the report is then generated with the Z-test framework from Zephyr.
Yeah, I was wondering how you was able to make it work, because I noticed Nordic programmer was resetting the debug port. So after flashing, it resets the port, so you get no output. And if you use J-Link, you had to comment some.
Yeah, but you can reach the flash, for example, and we use a power profiler for the current measurement. Yeah. So we have two tools basically. The current measurement isn't done by the J-Link. So the J-Link is just for flashing and resetting the MCU and navigating through the display, and the power profiler is for current measurement. And then you get this report. Sorry, I missed that point.
Thank you.
Yeah. Next.
Oh, no, just a quick remark. Very nice project. Thanks for putting that open source. And I also really like your setup with this UI development you can do in your machine locally, because as a software developer, it's such a big relief to have this UI living on your local computer, have a quick feedback, and that's really nice, comfortable setup for developing applications.
Yeah, the one nice reason, or one reason for this POSIX build is because of this flash usage. The programming of a watch takes a lot of time. So you need 1 minute to erase the flash because it's then slow, the external flash. Jacob has fixed it already, so it's a little bit faster now. But it takes up to 2 or 3 minutes to upload everything. And so the POSIX, it's not a good solution for fixing a bug, flashing it, testing, or it doesn't work, do it again. It takes a lot of time, so this POSIX build is quite nice for it, even without the emulators. And with the emulators, you also can develop the apps completely with POSIX. So it's a really, really good benefit of this Zephyr framework to add it. Any more questions?
You also plan to rework the firmware? Is it also included in that? Or right?
Yeah. Of course. Firmware is mostly Jacob's part. And I'm more on the hardware side, so all this hardware designs and keyboard stuff is from me. And yeah. But firmware is not that highly detailed planned, so it's more an ongoing process, a little bit Scrum-like, with only two people, so not much overhead, luckily. Sure. Any more questions? Okay.